Hello, we are looking at problem number 2 found on page 579 of your Geometry Part 2 textbook. This is actually in lesson 9.5 talking about congruent transformations. Now, there's a lot going on in this particular problem which can be a bit overwhelming, but let's just take it a little bit at a time. It says which pairs in the grid are congruent, and for each pair, what is the sequence of rigid motions that make one figure map onto the other? Now, figures are only congruent if the sequence of rigid motions to the map literally puts one figure onto the other. Now, the only way to do that is through translations, rotations, or reflections. They might flip it, they might turn it, they might slide it, but they will not change its shape. So that's what we mean when we say something has rigid motion. Okay. Now, let's look at DEF here, this triangle right here, because if I were to rotate, which is what this stands for here, the rotation of 180 degrees about 0, which is your rotation point or the origin, if I were to rotate this around, it would end up being this triangle right here, which they're calling LMN. Okay. So DEF, if you could imagine it being rotated around, it would become LMN. Okay. So that is one of the, that means these two are congruent to each other because I could do one rigid motion and get there. Now, for the trapezoid here that we're calling ABCJ, that one right there, there's actually a couple of things going on. First of all, to be able to map this onto this up here, it looks like that it got reflected over the y-axis. Okay, so if you could imagine this getting reflected over the y-axis, which would be over here, and then transformed, which is what the T stands for, 1 back and 5 up. That's what that stands for in this formatting. With the open arrow there, that means 1 to the left, and the 5 means 5 up. So once you were to reflect this over here, you would have to move it back 1 and up 5, and it would match on to this one right here, which they're calling WX, Y, and Z. So those would also be rigid motion. And then thirdly, if we want to start with line HG down here, which is just a simple segment of a line going from H to G, all we would really have to do is to slide this up and then over some, or you could say it slide it back some and then up some, same concept. Then that's what a transformation is just sliding the particular figure different places. So the transformation here would be 2 to the left and 9 up. That's again what that's standing for. So if you took HG and you moved it 2 to the left and 9 up, it would become PQ. And again, because those didn't change size, that's what we're talking about in here, which we call rigid motion, because it doesn't change size as it goes down through there. Okay. Now, in the got it section, it said which pair of figures in the grid are congruent for each pair. What is the sequence of rigid motions that map one figure onto the other? Well, let's start with the parallelogram or rhombus. I guess it's a parallelogram. Let's call it a parallelogram here. ABCD. It looks as though all we really are doing is we're going to slide it over and we're going to slide it down, and it would be in the same particular format that it was. So if I were going to write my transformation here, it would be, let's see, since we're sliding it, if I were going to take this point and go from here down to here, that is 1, 2, 3, 4, 5, 6, 6 to the right, and 1, 2, 3, 4, 5 down. So it's a transformation of 6 to the right and 5 down. And so that's the way you would write that particular transformation on that particular problem to get from one point on to the other. Okay, and that means that these two right here would be equal to each other because it's a rigid transformation. Now, to do the triangle, it's a little bit more hectic. This side matches this side. Okay, so there's a couple of things that are taking place in here. First of all, it looks as though that the triangle, well, there's two ways I guess you could do this. The first thing I did was I rotated it, which would put it up in this corner. If you were to rotate that 90 degrees, so it's a rotation of 90 degrees, again, about the origin. So that's one of the rotations that happens, plus or times the fact that then you would have to rotate it, which is a capital R, reflect it, which is a capital R, over the y-axis. Okay? And if you were to rotate this first, which you'd put it up to here, and then you were to flip it over, you would end up with that same shape, but it took two rigid transformations. And that one's a little harder to be able to see and to know that it was really 90 degrees instead of just 180 degrees and so on. But with time, you will learn how to do that a little bit better. But the whole fact of this particular section and chapter is not only recognizing the motions, but understanding that rigid motion simply means that whether you reflect it, or you rotate it, or you translate it, which means you slide it, that you're keeping the same shape as what the original shape was, which means that those two shapes will stay congruent to each other. That's the real important part of this particular example. Okay? Best of luck.